Arithmetic sequences and arithmetic series. A sequence is a set of numbers that are in order. So a sequence might be 3, 5, 7, 9, where 3 is the first term, 5 is the second term, 7 is the third term, 9 is the fourth term. If a sequence has 3 dots afterwards, it means it goes on forever, and so is an infinite sequence. The words term, element, or member mean exactly the same thing. Another sequence might be 4, 7, 10, 13, 16. This is an arithmetic sequence because every term has a common difference of 3. From 4 to 7 is 3. From 7 to 10 is 3. From 10 to 13 is 3. From 13 to 16 is 3. And with 3 dots afterwards, we know the sequence is infinite. The common difference is denoted by the letter D. So in this case, D is 3. Another sequence where the numbers go down might be 29, 24, 19, 14, ... Here, the common difference is -5. From 29 to 24 is -5. From 24 to 19 is -5. From 19 to 14 is -5. So we write D equals -5. The difference, D, is found using U2, the second term, minus U1, the first term. It can also be found U3 minus U2, U4 minus U3. So in general, D is found by UN minus UN minus 1. Any term in the sequence minus the previous term. In an IB exam, you will get the following 2 formulas. If you wanted to find the 100th term in the first sequence 4, 7, 10, 13, 16, you could just keep adding 3 until you got to the 100th term, but it would take a long time. In an exam, you can use the nth term of an arithmetic sequence, this formula. So, if you want U100, is equal to U1, the first term, 4, plus n minus 1, n being 100, so that's 99, times D, which is 3. So using a calculator, U100 is 301. You might also, in an exam, be asked to sum a certain amount of terms. If so, you can use this formula. You might be asked to sum the first 50 terms of the first sequence 4, 7, 10, 13, 16. So S50 equals n divided by 2, well, n is 50, 50 divided by 2 is 25, times 2 times the first term, which is 8, plus n minus 1 is 49. The common difference is 3. So the sum of the first 50 terms equals 3875. The following are typical exam questions. We'll keep the formula booklet close at hand. This first question is to be done without the use of a GDC. Consider an arithmetic sequence 2, 6, 10, 14. A. Find the common difference. So the common difference is any term, so u3 minus u2, which in this case is 10 minus 6, which is 4. B. Find the 10th term in the sequence. Because we want to find the 10th term, we can use this formula. So u10 is equal to the first term, which is 2, plus n minus 1, 10 minus 1 is 9, times the common difference, which is 4. So u10 is equal to 9 times 4 is 36, plus 2, 38. Part C. Find the sum of the first 10 terms in the sequence. We're asked to find the sum of the first 10 terms, so we can use the sum formula, this one here. So S10 is equal to n is 10, so 10 over 2 is 5, times 2 times the first term, 2 times 2 is 4, plus n minus 1 is 9, times d is 4. So S10 is equal to 9 times 4 is 36, plus 4 is 40, times 5 is 200. Or, because we were asked to find the 10th term previously, there is another formula, this one, where if you know the first term, u1, and the last term, in this case is u10, you can use that formula. Or S10 is equal to n divided by 2, which is 10 divided by 2, which is 5, times the first term, which is 2, plus the 10th term, which is 38. So S10 is equal to 5 times 40. So the sum of the first 10 terms is 200. Another typical exam question. Consider the following sequence of figures. You're given 3 figures made out of line segments. Figure 1 contains 6 line segments. Question A. Given that figure n contains 101 line segments, show that n equals 20. In this question, we need to find n. We know what un is. Un is 101. First thing we need to do is find d. So d is equal to u2 minus u1. So d is equal to 11 minus 6. So d is equal to 5. Now that we've found d, we can use this formula to find n. Therefore, 101 is equal to the first term, 6, plus n minus 1 times d, which is 5. Multiply out the brackets, so 101 is equal to 6 plus 5n minus 5. Therefore 5n is equal to 100, so n is equal to 20. We have proved that n is equal to 20. Part B. Find the total of the line segments in the first 20 figures. We are told that there are 101 line segments in the 20th figure. We are also told that there are 6 line segments in the first term. So we can use this formula to find the total number in the first 20 terms. So part B. S20 is equal to, there are 20 terms, so 20 divided by 2 is 10, times U1, which is 6, plus U20, which is 101. So S20 is equal to 10 times 107, which equals 1070. Another typical question. Landmarks are placed along the road from London to Edinburgh, and the distance between each landmark is 16.1 kilometres. The first landmark placed on the road is 124.7 kilometres from London, and the last landmark is near Edinburgh. The length of the road from London to Edinburgh is 667.1 kilometres. Because the landmarks are evenly spaced, we have an arithmetic sequence. D is equal to 16.1 and U1 is equal to 124.7. We want to find U5. Is equal to U1, which is 124.7, plus n minus 1 is 4, times 16.1 is 189.1 kilometres. Part B. Determine how many landmarks there are along the road. Right, London and Edinburgh are 667.1 kilometres apart. So we want to find UN is less than 667.1 to determine what the value of n is. Therefore, substituting U1 plus n minus 1d is less than 667.1, we can solve for n. Therefore, 124.7 plus n minus 1 times 16.1 has got to be less than 667.1. Therefore, n has got to be less than 34.7. N must be an integer, so n equals 34.